Hello everyone, welcome back to the channel. Let's try to solve this problem. Now in this problem, to solve it, we should know two important concepts. One is regarding the carbocation rearrangement and second thing is regarding the coupling reaction of phenol, right? Another thing which is important to know is the effect of electron withdrawing groups and the presence of electron donating groups in the case of coupling reactions, that how EDG or EWG affects this reaction. So let's go with the products and then see how we can solve it. Now the first thing required is the compound X, because the whole question is based upon the formation of compound X, right? From X we are getting the compound Y. Now in the case of compound X, what will happen? Now our reactant is here. So let's do it. In this case, just a second. Yes. Just a second. Our reactant is here. So it will react with concentrated sulfuric acid in the presence of heat. So basically, whenever we use concentrated sulfuric acid in the presence of heat, we have known that such kind of reagent is used in the case of dehydration of alcohols, right? But here there is no alcohol in this molecule. But yes, here is the scope of rearrangement of carbocation. And how it will happen? Let's try to understand. Basically, if I try to draw this molecule in upright way, right, it will be like this. This is the molecule which we have actually, this one, right? And we have double bond over here. Now, in the presence of acidic medium, what we will have? We will have the H plus ion. Whenever the molecule contains carbonyl group, C double bond O, and the medium is acidic, always remember the lone pairs present on oxygen will try to attack H plus ion and take it away. This is the first most step in every reaction where carbonyl group is there and the medium is acidic one. Right? Now what will happen? Once it will take away H plus ions, the oxygen will attain the positive charge here, like this. And because we know the positive charge of the oxygen is not stable one, what it will do? It will take away the shared pair of electrons from that pi bond towards itself. These electrons will go to oxygen. But the moment these electrons goes to oxygen, the carbon becomes positive charge. So to conduct the resonance, what will happen? This pi bond from here moves here, right? In the way pi bond empty orbital conjugation. So what do we obtain? We obtain the molecule which is like this. This is the molecule which we have obtained. Here comes OH and here comes the pi bond like this and here comes the positive charge. Now, if you look at here, the very important condition for the carbocation rearrangement or the ring expansion is what? For the ring expansion, what is the important condition? Is that just outside the ring, the carbon just outside the ring, or we can say the carbon just adjacent to the ring must contain the positive charge. And here that condition is already fulfilled, right? So in this case, if you look at here, what will happen? There will be the carbocation rearrangement, or we can say ring expansion. So what will happen? This bond, just a second, yes, these shared pair of electrons will be shifted here, right? In a way, there is a kind of what? A methyl shift, right? We can say the bond shift takes place here. Upon the bond shifting taking place, what we will obtain? We will obtain the compound like this. This is here, and here comes the OH, and the rearranged product will be something like this. Right, just a second. I think I have already drawn it again, same thing. Right, it will be this, it goes here, and instead of joining here, it will go here. Now, if you look here, the positive charge will come at this carbon. Here comes the positive charge, and here comes the pi bond. Right? Now, if you look at here in the ring downside, there are 6 carbons. One, two, three, four, five, 6. Right? In this way, there are 6 carbon here. So that means the rearranged product or will be like this. OH here, If you draw it here, it will be like this, and here comes the positive charge, and here comes the pi bond, and here comes the pi bond. Then finally what will happen, and here comes the hydrogen. Finally what will happen, when we will heat it, there will be dehydrogenation, right? Because we have already used H plus ion, and this H plus ion is coming from where? It is coming from H2SO4, right? So once we remove the H from H2SO4, what do we have? We have the conjugate base of it. This conjugate base will do what? It will take away the acidic hydrogen from here. Once it takes away acidic hydrogen from here, these electrons will go back to make the pi bond here. And what do we obtain? Finally, we obtain this molecule. Right? Just a second. Let me redraw it again. The compound which we obtain here is this one, with the OH and a ring bottom like this. So this is the final compound which we have obtained. Right? So the compound X is this one. This is the compound X which we have obtained. Right? Now the option says in the basic medium the compound X forms 9 canonical structures. Now canonical means resonating structures, RS. So if you look at here, I have already drawn these resonating structures for your reference, so you can easily match, right, by pausing the video for some time and easily can count on them that how we have drawn them. This is our product which we have obtained. In the basic medium, what will happen? This OH will lose, this is phenol, it will lose H plus ion forming the O minus. Then this O minus will undergo resonance, and hence we have obtained all the resonating structures. 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are total of 9 resonating structures here. So yes, our option A is correct. Right? Now this X compound is made to react with the diazonium salt. This is the diazonium ion. We are making the reaction of X with diazonium ion. Right? So let's try to do it. This is a compound which we have obtained here. This is the molecule which we have obtained as the X compound. We are making its reaction with this molecule. Now it is what? This is N2 plus, and here we have the Z, like this, right? This is a molecule which is going to react. And now we know the diazonium salt basically is what? It appears like this. It appears like this with the plus charge on nitrogen. Now what will happen, because we know diazonium is kind of electrophile in nature, because there is a positive charge here, and the lone pair on oxygen is what? The lone pair on oxygen is nucleophilic, right? And we know whenever the phenol forms the coupling reaction, whenever the coupling reaction occurs in phenol, always remember this thing. In the case of phenol, whenever the coupling reaction occurs, it occurs either from the para position or from the ortho position, right? This is what happens. But the phenol, phenol always prefers para position to do the coupling reaction. But if the para position is already occupied, as it is here, then it prefers the ortho position. Right? Now what will happen at the ortho position? What will happen? We know the resonance will take place, everything will happen. So finally, when the resonance will happen, the compound which we obtain, just a second, yes. What will happen here? This lone pair will undergo here, then this pi bond goes here. Once this pi bond goes to the carbon, this carbon, it attains the negative charge, and then this negative charge here will attack the nitrogen here, and the pi bond breaks back to go back to the nitrogen. And what do we obtain? We obtain the compound like this. In this way, we have the compound benzene here, and the molecule Z is here, right? This is the product which we have obtained finally. So if you look at the options, yes, option D is also correct, because D is the compound which we have formed here. The Y is the compound which we have formed here. Likewise, right? This is our compound Y. Now important thing is the effect of electron withdrawing and electron donating group. The option B says If Z is the electron withdrawing, if Z is the electron donating group, rate of reaction from X to Y increases. See, the point is the X compound we have obtained is giving us the nucleophilic site. That nucleophilic site is going to attack the electrophilic site, right? Here, this carbon, when it is the negative charge carbon after resonance, when it is going to attack the nitrogen here, what is happening? This is the nucleophilic site, right? And it is attacking the electrophilic site. Now, for attack, to make the attack more fast, right, and to make the reaction more progressive in the forward direction, what do we need? We need an electron withdrawing group here. Because if the electron withdrawing group is here, what will happen? It will make the N2 plus more electrophilic in nature, more electron deficient. And that will make the reaction go in the forward direction more, right? So the presence of electron withdrawing group in the case of diazine salt will make the reaction go fast. So if you see the options, it says if Z is the electron donating group, the rate of reaction increases. No, it should decrease. If the Z is the electron withdrawing group, the rate of reaction from X to Y decreases. Again, it is incorrect. Basically, option B and C should be reversed to make them correct, right? If Z is EDG, this is electron donating, the rate of reaction decreases basically. And if Z is electron withdrawing, the rate of reaction increases, right? So this is how we have obtained the correct options, which are option A and option D. So this is how we solve this advanced base problem. And as I have told you, two important concepts were there: carbocation rearrangement, coupling reaction, and the effect of EDG and EWG on the coupling reaction. Right? So I hope you understood this problem very well. We will come back with the new more problems for you. And for that thing, stay tuned, stay happy. Cheers. Goodbye. Thank you.